Hello friends, and in the last video we have studied a numerical related to differential equations of Laplace transform. Now, next one is problem number 2. But before moving to problem number 2, what I said, I think you should remember what I said in previous video is I am going to solve first 3 numericals on the basis of simple questions like find out inverse Laplace transform of differential equation, where the question is transfer function and the step response and the impulse response that you are going to find out. Now, and the next 3 numericals are based on output response, that is total output response, ZIR, that is zero input response, and ZSR, which is zero state response. So now, before moving to problem number 2, what is important? You should know the basic formulas of differential equations. Like if we differentiate y of t only once or twice or thrice, then what will be the result of this differentiation in the Laplace transform? So let's go through this page so that you can understand the differential formulas when it converts into Laplace domain. So Laplace transform d by dt of y of t, which means it's a first order differentiation. That's why I have written y dash of t only. The next part is what is the differentiation? If you convert it into Laplace domain, then as I told you the shortcut one also, if you are going to differentiate this function only once, then multiply y of s into s only. If the order of differentiation goes on increasing, similarly the order of s will also goes on increasing. We are going to differentiate this s y of s until this s value gets vanished. That's why I have differentiated once again this value. So differentiation of s becomes 1. So it is not written, and the y of s differentiation that I have written y of 0. Now look at here. In the second order, here we have Laplace transform of d square by dt square, which means here the order of differentiation is 2. Now, which term you are going to differentiate? That is y of t. Now, as I said, here the order is 2. That's why I have written double dash. So, in your exams, maybe they will give you this type of equation, d square by dt square y of t, or else they will give you the question like y double dash of t. The meaning of both these things are same. Now, as I told you, if the power or if the order of differentiation is 2, then of course we'll multiply y of s by s to the power 2. This power 2 is actually the power of differentiation. Now, what is next step? We have to differentiate this whole part until and unless this s value becomes vanished or will get vanish. So we'll differentiate once again. So this will become s y of 0 because y of is also differentiated with respect to s. And the last one, here again this s square is differentiated twice. That's why this y of 0 become big y dash of 0. Now look at here. Here the order of differentiation is 3, which means I'm going to write y triple dash of t. Then of course the first value in the Laplace transform is s cube into y of s. And I'm going to differentiate this whole part with respect to s. So first of all, this is going to be s square y of 0. Next part is s y dash of 0. And the last one is s y double dash of 0. Because here the s value becomes vanish. So please remember all these formulas. Just go through each and every case so that you can directly write the formula value in question whenever it is asked. So now what is important? We'll solve a problem number 2. Let's see. Now a problem number 2. What is given? A continuous time LTI system. What do you mean by LTI? LTI stands for linear time invariant. Linear time invariant means what? The function is linear, which means if you keep this or if you perform different operations on this equation, the response will not get changed. Now next term is time invariant. Time invariant means what? If you change the time value, then also output will not be changed. It will remain at its own place. Now, what do you mean by LTI? LTI stands for linear time invariant system. Linear means what? Linear means if you change the input, then also output will not get changed. Now, time invariant means what? If you change the time value, then also output will not get changed. Output will come at its perfectly given time. Now, so the question is a continuous time LTI system is initially relaxed. Initially relaxed means what? All the initial conditions are already given as a 0 or considered as 0. That's why it is mentioned initially relaxed, which means all the initial conditions that we are going to calculate or that maybe it is given in question, that we have going to assume as a 0. Initially relaxed means all the initial conditions are 0 and it is given in questions already. So no need to write it while calculating the inverse Laplace transform. Now, next one is, and it is represented as the given equation is y double dash of t plus 3y dash of t plus 2y of t and x dash of t plus 2x of t. Now, what is mentioned? Determine. The first one is transfer function, the second one is impulse response, third one is find the output response of the system. Here, the step response is not asked because here the x of t is already given, that is x of t is 4e to the power minus 2t into u of t. This is the x of t that we are going to substitute in our question to find out the output response. Now, so what is our next step? We'll find out all these three terms. First of all, we'll find out a transfer function of the system. But remember, here all in question, it is already mentioned the system is initially relaxed. Means what? The initial conditions are already given as a 0. Now, the question is y double dash of t plus 3y dash of t plus 2y of t equal to x dash of t plus 2x of t. Now, initial conditions are assumed to be 0, but basically in question it is already mentioned initially the system is relaxed, which means all the initial conditions are already considered as a 0 or given as a 0. Now, what is the next step? We have to apply a Laplace transform on this differential equation so that you will get the output in S domain. Now, in question, it is already given all the initial conditions are 0. Basically, it is mentioned initial conditions are relaxed, which means the initial conditions are given considered as a 0. Now we are going to find out the Laplace transform y double dash of t, y dash of t as well as x dash of t. Now, if you find out the Laplace transform of this differential equation, then of course it is having a initial condition terms. Now, in exam or in question, it is already given the initial condition is 0, so no need to consider it. And even in this solution, I'm not going to write that value, initial condition value. I'm going to write only the differential equation substitution or the Laplace domain value of it. Now, we'll apply a Laplace transform on all these terms, or we can say that I will apply Laplace transform on this differential equation. Now, we know that the Laplace transform y double dash of t, it is s square y of s minus sy of 0 minus y dash of 0. Basically, it is given in question, initially condition is relaxed or system is relaxed. So, I'm not going to write sy of 0 as well as y dash of 0. I'm going to write only the value of y dash of y double dash of t, and it is s square y of s. Now, just go through the Laplace transform properties of differential equation. You will get the idea why I have written Laplace transform y double dash of t as a s square y of s. Basically, when I derive the Laplace transform property in unilateral case, then you will get the initial conditions value. If you find out the Laplace transform in bilateral domain, then of course the y double dash of t answer is s square y of s. Similarly, now the Laplace transform y dash of t, it is s y of s. Now, the Laplace transform y of t is simply y of s. Now, again, the Laplace transform of x dash of t, it is s x of s, because here the differentiation order is 1. And the next one is x of t Laplace transform is x of s. So, I'm going to write twice of x of s. Now, what is the next step? I'll take y of s common, and from right hand side I'll take x of s common. Now, what we want, the first case was find out the transfer function of the system. The transfer function is nothing but it is the ratio of Laplace transform of output to the Laplace transform of input. Here the output is y of s and input is x of s. So already your terms are in Laplace domain. So only you have to take the ratio of output by input, which means we have to shift this x of s on left hand side and this constant part on right hand side. And this is nothing but the transfer function of the system. And this is nothing but the solution of part 1, that is a transfer function of a system. Now we will move on to second part, that is impulse response of the system. But for that, what I want, this equation is important. So that's why I'm going to write this equation is my equation number 1. Now, What do you mean by impulse response? Impulse response means what? First of all, you have to substitute x of t as a del of t. If your input is impulse function, then of course your output is impulse response. If your input is a step, then output is always a step response. Similarly, if your input is a ramp, then output is always a ramp response. Which means, first of all, you have to substitute x of t as a del of t to find out the impulse response. So, I'm going to find out the calculation or the solution of part 2, the impulse response. As I said, to find out the impulse response, your input must be an impulse function. That's why I've substituted x of t as a del of t. Now the Laplace transform del of t. As I told you earlier also, while calculating the Laplace transform elementary signals, in that also we have derived the Laplace transform del of t, and over there also, so I'm going to tell you the Laplace domain or Laplace transform del of t, or you can say that del of t is transformed into any domain, the answer is always 1. Means if you want to find out a del of t response in Laplace domain or in Z domain, that is Z transform, or in Fourier domain, the answer of del of t is always 1, which means x of s value is 1. Now from equation number 1, well, this was our equation number 1. What is important? We have to substitute the x of s value on the right hand side so that you can easily calculate the output response of system. So what I'm going to do, I'm going to multiply this x of s on right hand side. And what is x of s? X of s is 1. So if I replace this x of s by 1, then s, this whole equation into 1, this equation remains as it is. Now I want to calculate the response. Response means I want to calculate or I want to transform this y of s into time domain. How to transform this y of s into time domain, that is y of t? If you find out the inverse Laplace transform this y of s, then you will get the answer in y of t. So for that, first of all, you have to calculate the partial fraction. So for partial fraction, first important one is factors, and then we'll move on to partial fraction. So what will be the factors of this equation? Here the last term is 2 and mid term is 1. So I can say that 2 into 1 is 2 and 2 plus 1 is 3, which means our factors are 2 and 1. Now look at here. This s plus 2 and s plus 2 will get cancelled. So what will be there? Only s plus 1. So if you apply inverse Laplace transform on this y of s, then of course you can directly get the answer. Now here it is not necessary to find out a partial fraction. Here it is not necessary to find out, or it is not necessary to use a partial fraction, because directly s plus 2 will get cancelled. So answer is now s1 upon s plus 1. Now we will directly apply inverse Laplace transform on these two. So my y of s was 1 upon s plus 1, and now I'm going to apply inverse Laplace transform on both the sides. What do we get? Y of s is nothing but y of t, and look at here. What we have? 1 upon s plus 1. As the s is shifted by 1, which means here we are going to use a frequency shifting property. Now, what we are going to do? We will use a frequency shifting property. Now, what was the result of frequency shifting property? The frequency shifting property was, if you multiply any input signal by exponential function, that is let's say e to the power at, then all the s of that function will be replaced by s minus a, because the function exponential power, or you can say the value of a is plus. Now if your value of a is minus, then all the s will be replaced by s plus a. So reverse sign you have to use. Now here the s, we have s plus 1, which means the reverse value we have to use in the place of a. So your a is minus 1 into t is minus t. Now what s is remaining? 1 by s, and 1 by s inverse is unit step. And this is the result of impulse response. Now we will move on to third one. What is mentioned? The find the output response where the input was given. So we'll find out the third part of this question, which is the last part. Now we are going to find out the output response. Basically, output response means we have to find out the y of t. Basically, in equation number 1, the equation was y of s by x of s. Means what? The equation was already given in Laplace domain. So if you find out the inverse Laplace of it, then of course your result will be in time domain. Now, but before moving to output response, one thing is given, that is x of t is 4e to the power minus t u of t. So here we have to apply a Laplace transform, then you will get the answer in x of s, and then multiply x of n on the right hand side of y of s equation, or you can say in equation number 1. So first of all, I'm going to calculate the Laplace transform of x of t. So first of all, Laplace transform of u of t, and we know that it is 1 by s. Now, if you multiply it by e to the power minus 2t, which means we have to use a frequency shifting property. And this is now 1 upon s plus 2. What is the next step? We have to find out a Laplace transform of x of t, which means four into Laplace transform e to the power minus 2t u of t, and this thing you have already calculated, and it is 1 upon s plus 2. So my answer is, so this is nothing but our x of s. Now what is our next step? We are going to substitute this value in my equation number 1. From equation number 1, this was the equation number 1, y of s by x of s equals to s plus 2, and denominator we have s square plus 3s plus 2. Now we'll multiply this x of s on right hand side. Now I'll substitute x of s value, which is 4 by s plus 2. Now what you can say, that this s plus 2 and this s plus 2 will get cancelled. So my answer is y of s become 4 upon s square plus 3s plus 2. Now what is the next step? We have to find out y of t, which means first of all we'll have to calculate inverse Laplace transform, and before of that we'll find out the partial fraction values. What we have got, y of s equals to 4 upon s square plus 3s plus 2. Now what we want, y of t, that is the output response. Now to get the output response, first of all what we are going to do, we'll find out the inverse Laplace transform. But before moving to inverse Laplace transform, we have to use a partial fraction method. So before moving to partial fraction method, what will be the factors of this equation? As we have already calculated the factors of s square plus 3s plus 2, and it was s plus 1 and s plus 2. Now, what is our next step? We will assign a variable and then we'll move on to partial fraction. Now, my y of s was 4 by s plus 1 s plus 2. Now we have a 2 poles, then of course we'll use two different variables. Now, and this will be my equation number 1, because after getting a value of a and b, we have to substitute this value somewhere. That's why I have placed this equation, or I have marked this equation as a 1. Now, what we have to do? We have to multiply this denominator part, left hand side denominator part on the right hand side. Now, what you will get, s plus 1 will get cancelled, only the term is a multiplied with s plus 2. As I told you, the shortcut one also, just look at the denominators. Here both the in denominators we have s plus 1 and s plus 2, so only two denominators are there. So a will be multiplied with s plus 2 and b will be multiplied with s plus 1, and the denominator part, which is cross multiplied with each other, or you can say multiplied with each other, will get cancelled, because on left hand side we have the same denominator. Now, so what you will get? These two denominators will get cancelled. A will be multiplied with s plus 2 and b will be multiplied with s plus 1. Now, what is our next step? This will be my equation number 2. Now, substitute s value such that you will get a value of a and b separately. So, I'm going to substitute s equals to minus 2 in this equation number 2. If I substitute s equals to minus 2 in this equation, then this s is replaced by minus 2. Minus 2 becomes 0. So whole A term is multiplied with 0. So A will be vanished. Only the B term will be there. And now this S is replaced by minus 2. So minus 2 plus 1. Answer is minus 1. Now if you multiply both the sides by minus sign, then of course what you will get? B is equals to minus 4. Now we will calculate the value of A. Now how will you calculate? Just substitute S equals to minus 1 such that this B value will get vanished. So I have substituted S equals to minus 1 in equation number 1. Now what you have got? This S is replaced by minus 1, whereas if the B term was get cancelled, or you can say get vanished, because the whole S bracket gives us value 0. Now 2 minus 1 is, answer is 1. So my A value is 4 only. Now what is our next step? We have to substitute the values of A and B in equation number 1. What you will get? Now this A was 4 and B was minus 4. Now what is our next step? We have to find out the inverse Laplace transform. But now you can say that this 4 and this 4 you can take a common. So your answer is, well, basically it is not necessary. If you want, then you can take 4 common, otherwise keep it as it is. Inverse Laplace transform y of s is y of t. Now fold that I have already taken common. Now 1 upon s plus 1, as the here, look at here, this s is shifted by 1, which means we have to use a frequent shifting property. So according to shifting property, this is the value of A. Now the A value will be multiplied with t, but we have to choose the opposite sign. That's why I have multiplied it by minus 1. So minus 1 into t becomes minus t into u of t, plus here I have taken a minus sign inside this bracket. So over here the sign was plus I have taken, but if you open this bracket, then plus into minus becomes minus, so don't worry. Now the 1 upon s plus 2, here also this s is shifted by 2, which means my A value is plus 2, but while calculating the inverse Laplace transform, we will choose the opposite sign, that is a minus 2, and it will be multiplied with the t. So we have e to the power minus 2t. Now and the 1 upon s is left. So 1 upon s is nothing but my unit step. Now you can stop here also, as well as if you want, then you can take u of t common. So I'm taking u of t common from this equation. So my y of t becomes, look at it, in both the parts we have u of t, so I have taken u of t common. So we have 4 into u of t. Now if you open this bracket, then plus and minus will get changed to minus. And this is nothing but our output response when x of t is 4 into e to the power minus 2t u of t. So this is how we are going to solve all these numericals. Now we'll study a new numerical in next video, but for that stay tuned with Ekeeda and subscribe Ekeeda for further more videos. Thank you so much.